Okay, so this podcast is on Chapter 9, Lesson 2. And the essential question that we are answering for this chapter is how can you predict the outcome of future events? So, more specifically, what will we learn today? We are going to find experimental and theoretical probability. I don't know why it looks like that, and then also to predict future events. So, some vocabulary that we have for this lesson is uniform probability model. And if you look at the definition of uniform specifically, it means everything's the same. So, when you have a uniform probability model, it means that there is an equal chance of each of the outcomes to occur. So, when you roll a die, there is an equal chance of 1/6 of the time you to roll a 1, 1/6 of the time you'll roll a 2, so on and so forth. The theoretical probability is, in theory, what should happen. For example, if you found the probability of flipping a coin, when you flip a coin, in theory, like it says right here, in theory, you should flip heads 50% of the time and tails 50% of the time. Now, that doesn't always happen, and that is because probability is at random. Every time you flip a coin, you have a 50% chance of landing on tails and a 50% chance of landing on heads. And that probability starts over every time you flip the coin. For example, if you flip it twice, you aren't always going to have one being heads, one being tails. Now that's where experimental probability comes into play. So when you run an experiment, you don't necessarily know what's going to happen. So you can calculate in theory what's going to happen, and that's what we'll be doing. We'll be calculating the theoretical probability of what should happen to have an educated guess. Now, our experimental probability may not always be the same or may not even be close to what our theoretical probability is. So, if you were to flip a coin 10 times and record if you either land on heads or tails. Now, if you flip it 10 times, in theory, according to our theoretical probability, you should have 5 of them being heads, 5 of them being tails. Now, that's not always going to happen. You could flip it 10 times and only have 2 heads and 8 tails. So that's when we are going to compare our theoretical probability to our experimental probabilities. Now, the more trials that you run, the closer that these two are going to get. So if you were to flip a coin 100 times, now you may not get exactly 50 heads and 50 tails, but it's going to be a lot closer than it is when you flip a coin 10 times. So let's try number 1. So the graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Find the experimental probability of spinning red for this experiment. So, the graph shows us that the spinner landed on red 24 times, which we can read right there, and blue 15 times and green 21 times. Now, we want the probability of red, so I'm just going to write P of red, because remember that's how we write out our probabilities. Now, what we always have in the numerator is the number of favorable outcomes. So that's what you were trying to find the probability of, which we are trying to find the probability of red. So that will be the number of times red occurs over, it's always going to be our total possible outcomes. So that would be our total spins. So our probability of red is 24, because we know that, shown by the graph, that red showed up 24 times with the spinner. And the total number of spins, well, we know how many times green, blue, and red showed up. So if we just add all three of those together, we know how many times they spun the spinner, which would be 60. Now we can simplify this by dividing by 12 in the numerator and the denominator, getting 2/5. So our experimental probability for this event is 2/5. So now they are asking us to compare the experimental probability that we found to its theoretical probability. So the spinner that they told us about in problem number 1, it has 3 separate sections of blue, red, and green. So we know that one of them is red, one of them is blue, and one of them is green. Now, they said that they are equal sections, so we know that there is an equal probability of all three happening, meaning that is a uniform probability model. So, since there are 3 equal sections, the theoretical probability of spinning a red would be a 1 out of 3, because it's one of the sections out of 3 possible sections. So the probability, if we were to compare them, the experimental probability was 2/5, and the theoretical probability is 1/3, which those are pretty close, and I know that if you were to spin it even more times, you would probably get even closer, but since they had 60 trials, that's probably why they're pretty close. So now number 3. 2 number cubes are rolled together 20 times. A sum of 9 is rolled 8 times. What is the experimental probability of rolling a sum of 9? I would like you to pause the podcast and try this one on your own. So now for this one, we know that the probability of 9 equals, in the numerator, the number of times a sum of 9 occurs over the total amount of rolls. And they told us that a 9 was rolled 8 times with a total number of rolls of 20. Now this can be simplified down to 2/5. So our experimental probability of rolling a sum of 9 is 2/5. So now for number 4, they want us to compare the experimental probability that we found in example 3, which was 2/5, to its theoretical probability of rolling a sum of 9 when you roll 2 dice. So if the probabilities are not close, you need to explain a possible reason for this discrepancy. So I'd like you to pause the podcast and try this one on your own. So when you are rolling 2 dice, there are 36 possible outcomes. Now, I found this by knowing that there are 6 outcomes for the first one and 6 for the second one. And what you do with those 2 is you multiply them. We are going to talk more about this when we talk more about compound probabilities, but there are 36 possible outcomes. Now, to roll a sum of 9, there are only 4 outcomes. You can roll a 3 and then a 6, a 4 and a 5 and a 4, and a 6 and a 3. Now, since these 2 are pairs and these 2 are pairs, you're first rolling a 3 and then rolling a 6, so you can still list them as separate outcomes. That's why there's 4 and not 2. So, the theoretical probability would be 1/9, and since our experimental probability that we found in example 3 was 2/5, and that's not even, it's kind of close, but not really. So one possible explanation for this discrepancy can be that there weren't enough trials, because, as I said before, the more trials that you do, the closer you are going to get to having your experimental probability be close to your theoretical probability. Now, make sure that you are writing down any questions or notes on this lesson and coming ready to work in class on some fun worksheets and games to experiment with experimental probability and theoretical probability.